Hello YouTube, my name is John from Vulgar Kitten Studios, and welcome to episode 3 of How to Make a Video Game. And in our last lesson we actually got moving around, but what good is a tank if we can't fire projectiles? So that's going to be the topic for today. We're going to create projectiles and fire them from our tank's cannon, and we'll need to go ahead and take a look at our bullet prefab. We're actually going to make two versions of this, but for right now we're just going to use this one in particular. Before we get started on that, let's think about where we want it to instantiate. So we want it to instantiate obviously out of the top or out of the forward direction of our cannon. So let's just go ahead and grab our cannon and create a game object, create an empty child, and let's just position that right here so we can instantiate that bullet prefab and make it look as if it's coming out of our tank barrel. Alright, so put it maybe about right there. I'm going to rename this and I'm going to call that muzzle. And we'll actually need two scripts. We'll need one to fire the projectile and one to drive the projectile. So I'll go ahead and make both of those now. Make one called fire projectile and one called projectile. So okay, and let's just go ahead and grab our prefab and drop our projectile script on the bullet, and I'm going to take the bullet and I'm going to duplicate it, and the first one I'm actually going to call player bullet bullet, and one called enemy bullet, because we want to be able to differentiate between the two bullets. But either way, they're still going to use the same script. So now that we have that, we also want to make sure that we have sound effects on these, and I've already attached an audio source to the prefab, but we'll also need to make sure that we put our projectile sound effect on the audio clip. And I've just disabled all of the effects and turned play on awake on, so that way whenever this object becomes instantiated, it plays its sound as well. Okay, so let's go ahead and open up our fire projectile script, and we'll actually want to attach that to our turret. So grab our turret and put our fire projectile script on there. And we'll come in here. First of all, we'll need to know how much ammo we have, so we'll put a public integer ammo and make that equal to 5. And we'll need a transform for the, or public transform for the prefab that we want to instantiate, so public transform bullet, and we'll need a private transform to reference our muzzle object, and we'll use a couple of private floats, one for the rate of fire, so fire rate, and I'm actually going to make that equal to 0.1 f, and we'll need to store a next fire, and we'll need a regeneration rate, which we'll make equal to 3. And sorry, I thought I cut my mic off for a second. Alright, so now we'll need to actually grab our muzzle object, so we'll say muzzle is equal to transform.find child, and the child that we want to find is named muzzle. And before we go into our update, we'll go ahead and create an enumerator and call that replenish ammo. Because we only want to be able to fire 5 bullets at a time, because we don't want to have, a massive amount of bullets flying everywhere. And we do want to add some difficulty to the game as well. So we'll yield return new, wait for seconds, and regen. And then after that, we will increase our ammo count. In our update method, we'll go ahead and say if input dot get button up So once we release our fire button, which will be fire 1, our left mouse button, and, or, there we go, and time, so the amount of time that's passed is greater than our next fire, and ammo is greater than 0. Then our next fire will be equal to time plus our fire rate. And after that, we'll go ahead and instantiate our prefab, so transform.instantiate, and we'll instantiate the bullet at our muzzle dot position and its rotation as well. Like that. Also, we'll need to subtract 1 from our ammo count, so ammo minus minus, and we'll need to ensure that we start our coroutine to replenish that expended ammo. So we'll say replenish ammo. Okay, so let's go back into Unity and let this compile. And it looks like we have a error here, so that's because I made that I enumerable. It needs to be I enumerator. And IntelliSense sometimes trips you up like that. But okay, so let's grab our turret and go into prefabs and grab our player bullet and put that on a bullet. So let's play the game. Click our left mouse button and we instantiate our bullet. And it doesn't look like I saved my speed, but you can see that our timer is actually working for our replenish rate and our ammo fire rate. So before I forget, I'm going to go ahead and grab our player and drop his speed down. So the move speed, I'll set that to 1.5 and save the scene. And we'll go ahead and open up our projectile script. So go into projectile, and we did exhibit the behavior of the ricochet effect in our reference video, so we'll want to replicate that. And for that, we'll be using raycasting, so we'll make a public layer mask and call that collision mask. And we'll need a couple of floats, one for the speed, which we'll set to 3 by default, and damage we'll set to 30, and lifetime we'll set to 10, and damage radius we'll set to 0.05f, and we'll make a public boolean, and this determines whether it's the player bullet or not, so whether it's is player. And we'll also need an integer for a ricochet counter, because we only want to be able to ricochet one time. After that, we want to kill the bullet. And we'll also need to store information about the objects that we hit, so we'll say raycast hit, and that should be good. Also, we want to be able to, we have a pretty good level here, but there can be some collision errors, and if there ever are collision errors, then we don't want these bullets to just be flying around and eat up processor if they go through the walls. Let's hope that never happens, but if it does, we want to be able to destroy them at some point. So that's where our lifetime will come into play, and we'll set up an I enumerator and call it timed destroy. And in here we'll yield return new wait for seconds. The lifetime was lifetime and we want to destroy our game object. So game object.destroy and the current game object. So I have some red. I don't know why. I'm going to see if I have any errors. So that is because of what? That's because I never put an operator here. Alright, so that should make that go away. Okay. And now we'll just go ahead and call the time destroy in our start method. So we'll say start coroutine. And the coroutine we want to start is timed destroy. And so we'll go into our update and just go ahead and start moving ourselves forward. So transform.translate, and we'll translate in the direction of vector3.forward multiplied by our speed multiplied by time delta time for smoothing, and we'll create an anonymous variable for our array which equals a new array, and that is going to be transform.position is origin, and transform.forward is direction, and we'll say if our ricochet counter or our ricochet count is not equal to 2, or we could just say less than 2, but this works too. It's not equal to 2, then we want to perform our raycasting. So we'll say physics.raycast, and we'll use our ray, and we'll get the information of what we hit, and the length of the ray time.delta time times speed plus 0.05 f for padding, and then the collision mask that we are going to set in the inspector. So it can only perform this on this layer. All other layers will be ignored by this raycast. And we'll set a vector3 and call this reflector, and we'll use the vector3.reflect method, and we'll use the ray.direction and the hit.normal. That would be like the render normals of the object that we hit. If you know anything about how objects are rendered, basically it's just the face of the object whenever you see a video game, pretty much. So now we'll make a new float and call it rot for rotation. Add the 90 degrees on there and subtract mathf dot arctangent 2, and use reflect direction dot z and reflect direction dot x for the y, or for the x, I'm sorry. Reflect direction dot x, and then multiply that by mathf dot rad to deg, which means radians to degrees. We will convert our radians to degrees, and use transform dot Euler angles to equal the new vector3, and 0 for the x, rot for the y, and 0 for the z. And then we'll just increase our ricochet counter. Okay. And if our ricochet check doesn't pass, we'll just say else destroy game object. Well, we'll say game object dot destroy, and then the game object. And that should be enough. Let's go ahead and go over to Unity. And the very first thing that we need to do is go to our player bullet and make sure that we tick on that is player boolean to make sure that we know that this is a player projectile and not an enemy. So let's go ahead and play the game. Well, actually, we didn't specify any layers for it to bounce off of, so it won't work. Alright, so in order to do that, let's go ahead and grab our level and go to our bottom wall and just go to add layer, and on the 8th layer we'll say obstacle. Okay, so we've created a new layer obstacle, and for our bottom, or for all of our walls, bottom, right, left, and top, we'll just shift click to select all of those and change those to obstacles. And yes, we want to change them to children. And then we'll go back into our bullet prefab and set our collision mask to obstacle. Make sure we did that on our enemy too, because we want their bullets to reflect as well. So obstacle. I'm just going to Control S to save the scene real quick, and then we'll play the game. And so I'll shoot, and we can see that our reflection is working, and it only reflects once, or it only ricochets once, and then when it hits again it destroys itself. So let's see if I can get one right outside the level. See if it'll work. So I know there's a sweet spot somewhere right here where the colliders don't exactly meet. There we go. And let's just watch it. And it'll wait for about 10 seconds and then destroy itself. There we go. So even if collision errors do happen like that, then it won't eat up your processor for no reason by being in the game. Alright, so I hope you enjoyed this tutorial, and I'll see you in the next one.